Hello, I'm Lewis and this is DIY Machines, the channel where I get to share with you step by step how to build awesome projects. And in today's episode, I'll show you how to build this working pair of replica walkie-talkies as used in Netflix's hit TV series, Stranger Things. Recently, I finished watching Stranger Things and really enjoyed the nostalgia and fun of the two-way radios being used. I have fond memories of playing with some when I was a kid, and the shows reignited that desire, so I set about recreating a pair for me to play with. Hey Will, when I grow up, I think I want to make videos on YouTube.
What is YouTube?
I don't know. This video has been sponsored by PCBWay. I'll tell you some more about their services later. The radios use the 446 MHz spectrum, and after testing them, they have a range of about 1.5 kilometers in the open air and roughly 300 to 500 meters in some built-up locations. So I did have a look into designing my own electronics and PCB for this project, and the complexity and cost was rising. That's when I noticed you could actually buy this pair of radios on Amazon for less than £19. So in a first for me, we're gonna scavenge the electronics out of these radios. We're gonna repackage them into our 3D printed housing, add some additional elements such as the red LEDs and the decorative antennae to help sell that nostalgic radio look. So to build one of your own, you're going to need to get yourself a donor radio, a pair of red LEDs, a 100k resistor, a magnetic telescopic pen and some bolts. It would also be ideal if you got yourself some heat shrink tubing or a roll of insulation tape to help protect the circuit later on. And as always, you'll find a list of these parts and links down below the video. You're also going to need some 3D printing filament for the printed parts. I'm going to print all of mine using PLA in white, red, matte black and a silk silver. Throughout the video, I'll give you the files and show you how to do it with a single color 3D printer and with a multi-color 3D printer as well. We'll get going by first disassembling our radio. First, we remove the battery and then pull off the two dials at the top. Underneath these dials are circular nuts, which we can use a flathead screwdriver to turn anti-clockwise to untighten and then remove. After this, we can pry off the silver back piece. Lift from the bottom, alternating the sides to loosen it by its tabs, and then carefully pull up and partially back out the bottom, as we first need to cut the two speaker wires roughly halfway along their length, before then fully removing that silver back piece. To remove the speaker, start by taking away any of the glue you might see around its edge, and then carefully pry it up at the sides. Next, unscrew and save the two screws from the electronics board to separate it from the silver chassis. Now that we've disassembled our donut radio,
Disassemble! No, disassemble!
We can start reassembling it into our 3D printed housing. So we'll start off by printing the middle section of the radio body. If you've got a multi-material printer, then go ahead and print the file radio body middle-multi. And if you have a single nozzle one, you can go ahead and print the radio body middle-single and the two silver inserts. For now, we'll just take the solid silver one and we'll glue it into position on the side here. Now we can start to put some of the electronics into the front section of the radio. For the multi-material printers, you'll want to print the radio body front multi, and for the single nozzles, it's radio body front single. Now, as you can see, of course, the multi-material one comes with all of the markings already inscribed, whereas we just have indentations on the single nozzle one. Now, there's a trick which I picked up from another YouTube channel called Fuzzy Logic, who I've linked up here at the top. You essentially thin nail polish with acetone and then use a 1 milliliter syringe and a blunt tip needle to add the polish into the inlays. You'll need a steady hand and can wipe away any excess. Perhaps, thankfully, the fact that these radios are supposed to be old allows it to be less than crisp, we'll say. We'll fit our two LEDs first, which will be wired in parallel through a 100 ohms resistor. You'll find that LEDs have a longer leg on one side, and this marks the positive side, also known as anode. The negative side, you'll find the shorter leg and also a flat notch on the LED itself. The negative side is also known as the cathode. First, push fit the two LEDs into their cutouts so that the two positive legs are towards the middle. We can then bend them together and solder them in place. Trim away any excess. To this, we'll then solder a 15 centimeter long length of wire. For the negative cathode side of our LEDs, use a short length of wire to join them together close down to their bases. And then we'll use another 15 centimeter long length to connect one of the cathodes. I then added some hot melt glue to both hold the LEDs into place and to help prevent any of our wires from short circuiting later on. Taking our resistor, you can attach it to the open end of our positive wire, leaving the other leg long. Now is a great time to pop some heat shrink onto this wire, ready for later on. Now we'll extend the wires on our speaker with a pair of 8 centimeter long wires. And if you were unfortunate like me and you accidentally broke a wire off earlier, you can just solder your extension directly to the speaker. It's no problem. The speaker itself can then be popped into its little recess, and some hot melt glue used to hold the speaker in position and to act as a strain relief on our cables. You're going to need to pass the speaker and LED wires through the cutouts so that the front panel can be attached to the printed middle section of our radio. Use 4 M2.5 by 10 bolts to attach the printed parts together. With this in place, we can now take our circuit board, which we scavenged earlier, and begin attaching the components to it. First, take the other end of the resistor attached to our LEDs and solder it to the pin marked VCC on the radio's circuit board. This will provide us with a regulated 3 volts when the radio is switched on. The wire coming from the negative cathodes is attached to the ground pin on the circuit board, being very careful not to bridge the gap between the two pads. We can now insulate these connections using the heat shrink that we added earlier. And if you're not using heat shrink, then I'd recommend at least some insulation tape. Next, the speaker wire can be reconnected where we made the cut earlier. As before, Sift some heat shrink around the wire before soldering it together, or use insulation tape to protect the circuit from shorting. Now, just before we install the circuit board, check that this blue silicone sleeve is still over the microphone. Then lay the board down in position, ensuring that none of your wires become pinched. Fix this in place using the same 2 screws that we removed from it earlier. I want to take a quick moment to tell you about this video sponsor, PCBWay, who, as the name suggests, manufacture PCBs. I've been using them to do this for almost 5 years now for my projects and hobbies. But did you know that's not the only thing they do? They can also provide you with PCB assembly, 3D printing with all sorts of materials and processes, sheet metal work, and CNC machining. This means you could have everything you need manufactured for your project by PCBWay, making them a true one-stop solution. Swing by their website at PCBWay.com, and if you're a new customer, they'll give you a $5 welcome bonus. And being as 5 PCBs under 10 centimeters squared only costs $5, you literally only need to pay for the shipping. So that's PCBWay.com, and thank you for sponsoring this video. Now, to connect the volume and channel knobs here at the top, we'll need 2 more 3D printed parts. Pop just a small amount of glue into the recess in the bottom and then fit it over the dials on the circuit board, ensuring that they are firmly pressed down as far as you can without damaging anything. The 2 original knobs are then push fitted on at the top of the housing. Turning our attention to the battery pack, we can print the rear of the radio and install the battery with 2 M2.5 by 10mm bolts. Then solder a pair of 18cm long wires between the battery terminals and the terminals on the circuit board, being very careful of the polarity. Please be careful not to short the battery terminals or apply too much heat for too long, as we don't want to damage the pack. Plus, we also need to be respectful of lithium-ion batteries. If you lay the parts side by side, the 2 inside connections are the negative terminals, and the 2 outer ones here are the positive connections.
Power on. 1, 2, 3. 1.
For the decorative antenna that goes on top of our radio, we'll take our telescopic magnet and pull off the top piece. Hang on. Pull off the top piece. Hey! This can then be collapsed down, inserted from inside the radio. To help prevent it from sliding downwards when retracted, you have 2 options. Either apply some glue where the arms hold on to it, or use another M4x18 bolt and lock nut to hold it using this adjustable slot in the side of the print, like so. Now that we've finished with the interior of our radio, we can attach the rear plate onto the main body using the last of our bolts. Then the decorative detail for the antenna on top is slid over the antenna and glued into place at the base. The top of the rod can then be carefully reinserted. Now that we don't need access to the bolt hole here on the left, we can finish assembling this side of our radio. Multi-material printers need to print the left-hand side panel -multi, and standard printers should print left-hand side black -single. They'll also need to glue in place the second silver side with holes that we printed earlier. So for the button that goes into the side of the radio to start the transmission, I have created them in a variety of depths so that you can find the right size for your project. I'd recommend starting off by printing the one that's 15mm long and seeing how that goes. They're available in 0.5mm increments between 14mm all the way up to 17. To test it, take your side piece and insert the button. You may have to bend it slightly to get the part inside. You can then hold it up against the radio and see if it allows you to click the button and release it as well. It's important that you keep the plate pushed up against the radio whilst testing this, because this is how it's going to be held when we glue it. If yours isn't engaging and releasing as it should, then just try a different size of button. You're certain to find one that fits. After the correct button has been found, we can glue the side panel onto the radio, ensuring that you don't get any adhesive near and certainly not onto the button itself. And there we go. Now, if you bought a pair of radios like I did, feel free to convert both. But if you keep one in its original form factor, don't worry, it will still work with your new creation, which will also work with most other brands of radios on the same frequency as well. Thank you for watching all the way through to the end. If you'd like to support projects like this and help me create, document and share more videos, please consider becoming a YouTube member here on YouTube or a patron. You'll find links to both of them down below this video. Please don't forget to like and subscribe, and until the next video, do some good and ciao for now. Need 2 more 3D printed parts. SBC port at the bottom into a connections with the hinged